Hello, everyone. Really excited to be here today with all of you to tell you about what we've been up to at the BigQuery Migration Service. So, migrating your data ecosystems to cloud helps unlock the value and potential of that data. However, migrations to cloud have historically been difficult, unpredictable, expensive, and kind of open ended without a good idea of how long the migration itself is going to take. Plus, they rely on a smattering of tools in the ecosystem, and the process is very friction filled, if you will. We've been building the BigQuery migration service to make the end to end migrations to Google Cloud to BigQuery as easy, smooth, seamless, and automable as possible. To that extent, uh, within the last few weeks and few months, we've announced two major offerings from BigQuery Migration Service. The first one is assessment, which was announced for Teradata as publicly available for Teradata earlier this year. And assessment helps with a few things. First of all, it helps answer the question, how complex is my migration? How should I be planning for that migration? What are going to be the more difficult pieces? What is going to be the cost once I migrated for my running workloads? How do I go about planning for all of this? So, assessment is an offering that helps answer all of those questions and is available for Teradata. And we will be adding more sources to assessment throughout the rest of this year. Once you have a migration plan, the hardest part in any migration is moving over your code objects, translating your code objects from your source to BigQuery in this case. So the SQL automated SQL translation service that we launched for 10 dialects in June is going to help with automated migration of your SQL code objects, DML, DDL, and it's intended to be as helpful to the user as possible. And that's where we're going to be spending most of our time on. We also have a demo for you uh, to show you how the service actually works. Now, automated SQL translation is available in two flavors, batch and interactive, and we're going to be talking about each of those. Once your code objects are translated, we have the data transfer service that's available for migrating your data from Redshift and Teradata to BigQuery. We are going to be adding more sources to the data transfer service in the near future as well. Once your code is translated, your data is moved, you would want to validate your workloads between your source warehouse and BigQuery. And for that, we have the data validation service that performs a by row, by column, highly configurable left to right comparison between your source data warehouse and BigQuery. So just to recap, together these four pieces, assessment, automated SQL translation, data transfer, and data validation, comprise the BigQuery migration service. And most recently, we have launched assessment for Teradata, as well as launched automated SQL translation for 10 sources. Let's jump right into it. What is automated SQL translation? Well, it's uh, it's a service which is applicable or which is usable by different user types, different user personas. Whether you're part of an organization, you're a data engineer and part of an organization that's helping either your company or a customer of yours migrate, and you want to perform a lot of customization into how your code works, or you have a lot of customization. The automated SQL translation batch mode caters to that. Or if you don't want to roll up your sleeves a lot and you want Google to take care of a lot of those moving pieces, we have utilities and we have the capability with an automated SQL translation to address that as well. Let's talk about the two modes first, and then we can talk a little bit more about what is expected of what can be expected from each of these modes. So batch mode, as the name suggests, it's a powerful, performant application that helps large-scale code migrations. It's available via the UI, the Pantheon UI, public API, as well as with client libraries. If you either want to highly customize or you have highly customized code outputs, and you are a power user, and you want automated code translation with your customizations in place, we have an optional client-side helper tooling that is maintained by Google, maintained by us, but is open sourced. So the client-side tooling, helper tooling, actually helps the batch SQL translation service. Another use case for this client tooling is if you just want to run the entire translation from your ecosystem, which means from your source, and don't want to engage with the UI or the API, then the client-side helper tooling allows you to do that as well. And we'll talk more about it in the demo. The other mode is interactive translation mode. Now, this is meant to be one of two things. One is if you are, again, a data engineer who's performing SQL translation, and you want to pick up a piece of code, and you either want it for debugging or for understanding the behavior at BigQuery, you can do real-time Google Translate like code conversion from the 7 sources listed on the slide to BigQuery. And this is more real-time, gives you an interactive Google Translate-like experience, is available through the BigQuery UI. The other persona that the interactive SQL translation helps with is in your organization, if users, analysts, data engineers want to build an understanding of BigQuery SQL, then this tool actually helps accelerate their learning. So it delivers value from multiple angles. As I mentioned earlier, right off the gate, we have launched automated SQL translation with a large number of supported sources. What are the key salient facts, or what are the key differentiators for automated SQL translation? Number one is it's totally free to use. You're only going to pay for BigQuery usage. Second, really cool feature is that translations are source context aware, meaning it will, if you provide it with information about your source system, about your specific workloads, it is going to use that information in translating to BigQuery. The third is, and this is where you'll see a lot, this is where we double click a lot in the demo. It's intuitive, meaning that once you run the translation, not only is it easy to run, but the output also is based on what should the next actions for you as a user. What should be the next actions for you as a user? And those could be nothing for most of the scenarios, to reviewing some of the translations for consistency or lack thereof between the source and dialect and BigQuery. Or it could be looking at some optimizations or some suggestions. And so the output actually lists out each of these. Finally, it's automated not only in the translation, but also in logging any issues that it encounters. So this is a real cool, nifty feature. You don't have to worry about filing any bugs that might be encountered. And the software is smart enough to log issues when it recognizes that it wasn't able to successfully translate something. And this is a huge, huge cost and time saving. Not having to file bugs, not having to follow up for most scenarios on bugs. So that's automated SQL translation. Without further ado, let me invite my colleague Zihao to show you a real cool demo. Over to you, Zihao.
So this is essentially a tool to help the migration admins to convert SQL queries at a large scale. And users can essentially capture the SQL files and then upload to a customer-owned GCS bucket and then trigger a translation job here. And the job will essentially do in-memory processing and then generate the corresponding translated SQL queries in output files. And to find the batch translation service, users can go to the BigQuery page and then in the migration section and choose the SQL translation tab. So for the demo, let's start a SQL translation from here. So we need a display name, we need a location to specify where the job will be submitted to, and then the job will run there and process the files. We also need a source dialect, and for now we support 10 plus popular source dialect. And for demo purpose, we'll take Teradata and SQL. And the target dialect will obviously be BigQuery. So this means we translate from Teradata query to BigQuery query. The next step, we need to specify the source GCS location. And this is basically the GCS path which contains the translation input files. So for the demo purpose, I essentially created a demo folder. And in the demo folders, we have many interesting SQL queries in Teradata syntax. And let's just choose this folder as an input. Next step, we'll also need a translation output folder. And this folder will essentially contain the translation results generated there. Similarly, let's choose a demo parent folder and then the output subfolder. We also have the optional settings. And for most of the translation use case, users don't need to set the optional settings. But if you want to do some advanced behavior control on the translation, then you can just update the settings here. The first option we have here is a default database. This is basically used for the SQL objects which don't have the database name component. And in that case, if you specify the default database name, the translator will use this as a database name for objects which don't have a database name part. And in this case, it will be able to define the fully qualified name for the SQL objects. Similarly, for the schema search path, this is a list of schema names. The translator will also search through for the objects which don't have the schema name, and it will also compare against the DDL and to figure out the fully qualified name for the SQL objects. We also have the SQL output name mapping features in preview, and this is basically a way for users to rename the SQL objects during translation. And users can essentially configure the mapping rule to update one name to a different name. So what we have here is we have a 4-level fully qualified name mapping, starting from database schema all the way to relation and attribute. And database is basically the GCP project equivalent, and schema is a BigQuery dataset equivalent. Relation is a BigQuery table equivalent, and attribute is a BigQuery column related equivalent. So by configuring the mapping rules, user essentially can rename the table name, column name, or data set name, for example, during the migration. So for the demo, I'll leave these optional settings as empty and then just to trigger the SQL translation job. So the job will be submitted to the backend, and then the worker will pick up the job and doing the async processing there. Users are free to close the tab and come back later to observe the results. We can also take a look at a previously finished job. So if we just click the row, we'll go to the details page of the job. So here we will have some high-level statistics, such as the total number of statements we discovered during the translation, and the total processing duration, how long the job runs, and come to the finished state. And also we have this percentage translated to show how many of the queries we translated. Down below, we also have this action tab, which basically summarizes the actions users can take to further improve the translation accuracy and the success rate. So the actions are essentially grouped in a tree view. At the top level, we show the actions users can take. And if we expand, we can see the translation issues, translation issue categories related to the action. And one level further, we will see next the concrete translation issue error messages. And then if we open the last level, then we show the files which encounter the translation issue. And users can just click here to go to the file and to do more troubleshooting there. And the tree view is powered by the structured raw data, which is captured in the batch translation report.csv. Users can essentially download the CSV from the translation output GCS bucket and then do further analysis from there. We also have this translation configuration tab, and this tab essentially summarizes the settings user choose when they submit the translation job. And the resource name is basically the interesting field that we use this as the translation job ID. So if you have some interesting job that you want us to take a look, then share this resource name for us will be super helpful for us to search through logs and then find out the corresponding information for troubleshooting. So this is basically the batch SQL translation service and interact with that from the Penson UI. We also provided open source tool. Let me switch to that. So this open source tool is basically a Python exemplary client, which automate all the steps you need to do the batch SQL translation. So you can find this tool in the DWH migration tools GitHub repo, and then under the client. So what this tool does is it basically automates the local SQL files uploading to GCS buckets, then trigger a SQL translation job, monitor the job to finish, and then download the translation output back to the local machine. So if you want to basically skip the Penson UI part, or you want to skip dealing with the GCS buckets, then this tool will be super helpful. Or if you want to build some Python scripting on top of the batch SQL translation service API, like you want to build some translation automation or some translation pipeline, then take a look at this exemplary client in Python will also be a good starting point. So this is basically everything about the batch SQL translation. And then we also have another SQL translation service called the interactive SQL translation. And let me switch there. So interactive SQL translation is more like a convenient tool for the data analysts to convert the ad hoc SQL queries. This provides a Google Translate-like experience, but this is mainly for the SQL query conversion instead of the natural language. So users can find the interactive SQL translation in the BigQuery SQL workspace and go to the More button and then enable SQL translation mode here. So we can see the BigQuery query editor become a split view. On the left-hand side, we can input the Teradata query, and on the right-hand side, we can see the translation output in BigQuery syntax. So for the demo, I essentially have this demo table, which captures the one year Google stock price for 2021. So let me just to quickly do a select and show the data. So notice I put the Teradata syntax on the left and then click translation. So this will generate the SQL query in Google SQL, and then users can also just run the SQL on the right-hand side, and it will query the BigQuery data. The prerequisite is obviously that you need to make sure the table name is aligned with the actual table name in BigQuery so that it can reference the actual data. So user can also just leverage this interactive translation tool to do more advanced translation and to do more advanced data analytics, and assuming like the user is more familiar with the Teradata syntax. So the interactive translation tool will be super helpful to make that more productive for the user. So the next example, I essentially have two queries here. And the first query is a DDL, just to define the definition of the daemon table. And this also tells the translator basically the type of each columns. And the second query is a trading strategy that we want to buy one share of the stock at the beginning of the month and then sell that at the end of the month. And we want to say if we do this for the past 1 year, how much money we can make. So again, we do the translation. Both of the SQL queries will be translated. And since we only care about the second query about to calculate the profit, then we can also just highlight it and just run the second query. And observe like we can make $810 if we follow the strategy last year. So the interesting thing here is like to make sure the second query is translated accurately, I need to include the DDL of the demo table. The reason of this is because right now the interactive translation is stateless, so we don't take other external information to assist the translation. Therefore, in order to make sure the translator understands the underlying types of each column in the table, then include the table definition here will be super helpful, so that the translator knows the type, and then the translation based on the type will also be more accurate. For example, like we have this cast, and then the translator needs to understand the type to make the proper translation for the cast. And for interactive translation, we also support multiple input dialects, and users can essentially go to the translation setting and then switch from Teradata to other popular SQL dialects. So this is basically all about the interactive SQL translation service. So right now, both batch SQL translation service and the interactive SQL translation are GA. So it's publicly available. No allowed listing is required. And then this is also a free service. So if you do have some migration workloads and you need some SQL translation capabilities, then feel free to try out the services and let us know how everything goes. Thanks.
Thank you, Ziaul. Thank you for that demo. We hope that you found this information useful and you would give the BigQuery migration service, especially assessment and SQL translation, a try. And we look forward to working with you and helping you in migrating you and or your customers over to BigQuery. Thank you very much.